And for our last talk of today, we're going to bring on Kautuk to tell you about how do you think about general purpose versus application-specific systems. And this kind of includes everything about rollups, VMs, stuff you're seeing in ZK, stuff you're seeing about risk. All that stuff is all part of this way to think about and understand this. So please give Kautuk a massive round of applause.
Hello. Thanks, Karthik. Hey, everyone. So my name is Kautuk, and I'm the founder of Stackr Labs. I'll talk more about it in the coming slides. So the topic for my talk is general purpose versus app-specific systems. I've kept it like a pretty broad overview of different things, and then I'll go over what's the best fit for you. So a little bit about me. As I mentioned, I'm the founder of Stackr Labs, and we are building something called as micro rollups. And before that, I like doing protocol research. Before that, I worked on Hubble L2 and BLS Wallet at the EF, and then I also moved the LivePeer protocol to Arbitrum. So coming back to the topic, so this is a basic example of what general purpose system is versus what something purpose built can do. So a pickup truck can do a lot of things. It can drive, it can tow, it can store stuff, but an excavator would excavate, and it can do so that pretty well. Similarly, a more software example would be on the Web2 side, we have Twitter, and then we have TikTok. So with Twitter, you can have things like text, images, photos, videos, audios, whatever you can think about posting on regular social media, and then on TikTok, you have short videos. Which one is better? That's a very subjective thing. I don't think anyone is better than the other. It's just that one serves the purpose for which it's built for. And then more crypto native, or a Web3 example would be Arbitrum versus DYDX. So Arbitrum is more of a general purpose chain. You can deploy any kind of application on it, whereas DYDX is a more closed system wherein it has been optimized pretty well for doing trading. So again, coming to the definition, general purpose, it does a bunch of things all at once, whereas app-specific systems are purpose-built for very discrete use cases. And sometimes app-specific can be loose, and sometimes can be very strict. Then you can split app-specific into domain-specific. It's going to come a little bit later. So is one better than the other? So that's the question that we are trying to answer. So let's talk about it one by one. So coming on to this famous quote, which is jack of all trades. So general purpose systems, the features of them are they have substantially lower entry barrier because everyone uses it. You know how it works. There is a lot of tooling and support for it available on different forums. So you get familiar tooling, you have a lot of people building on it already, and it can also act as a base for many app-specific use cases. So it's not just you are limited to that general purpose system, you can have it as a base for other systems as well. So some of the examples in terms of chains are Ethereum, Solana. You can have ZK VMs, which are SP1, RISC-0, and there are other examples as well. So very, very it's going to be a reach, but there are some specific cryptography as well. So I think Remy talked about FHE. That's a application-specific cryptography wherein you only care about encrypted data, whereas later there's just general-purpose cryptography like ECDSA, signature verifications everywhere. But jack of all trades, master of none is something which we have all heard about, so there are problems with it. So general purpose systems, so Ethereum has scaling issues. We have all been working around it. So we have been building rollups, different solutions for it. Solana has decentralization issues because of the system requirements that it has. It's a very high system requirement. You lose some of the decentralization because of it, but then again, it does that does the parallel transaction very well. And with ZK VMs, they are not too efficient, so we have been recently benchmarking a lot of different ZK VMs, the general purpose ones that target RISC-V architecture. You can run a bunch of compute on that, but they are not efficient. So if you are doing something very specific, you are bound to write your own ZK VM from scratch, or just write circuits which are able to do those kind of things that you're looking for. So these are the specific issues for us. A general purpose that just does too much. That is not generally for scale. So you can build applications which goes up to a certain extent, which is the limit of that particular system. And then you always have some compromises attached to it. So the compromises could be in terms of compute. It could be in terms of noisy neighbor problem. You can be limited by a set of different things that you can or cannot do with it. So how about bespoke systems? So I talked a lot of things about general purpose systems. So am I trying to get in beef with all the systems that are out there? So is bespoke systems really the best? So some of the features of app-specific systems are that they're infinitely scalable, and when I write infinitely, it means that you can choose to do whatever you want with it to a certain extent, or like in the scope of your application or something like that. And they're useful scaling because if you're building something very purpose-built for your use case, you can just customize it to the extent that it can go to. And definitely, there's a lot of room for innovation. So, for example, like if you guys know about Formula One racing, most of the advancement in car technology has been coming from like those racing advances. So all the aerodynamic stuff, all the engine performance, all of those things. Formula One is a very application-specific thing, but then that rolls down to general-purpose things like regular everyday cars. So some of the examples are like chains which are purpose-built. So Celestia is a chain that is purpose-built for doing data availability. I mentioned about DYDX, and then there are other chains as well which are application-specific for for different purposes. Then for example of ZKVM, so there's Maiden, which does private computation on like, it's an L2 that does like private transactions. Then there's Delphinus, which is a WASM-based ZKVM, and it can run WASM very well. If you try to run WASM on a regular ZKVM, it's just not gonna work. And then there are DSLs like Cairo or Noir, or like some other languages as well. So these are like purpose-built for doing cryptography and those kind of things. And obviously there are a lot more examples around that. Yeah. But at the same time, even app specificity has a lot of like issues with them. So to develop, it's a little bit difficult to develop on DSL. So you have to have like a very good understanding of the system itself to understand what's happening, how things work, how to resolve bugs, and all of those kind of things. Bootstrapping applications as well as ecosystems is hard, because to build a particular application for a particular system, you need to understand the nuances of the system. You need to understand the nuances of the ecosystem that's going to like that particular system. And similarly, since something is very small, it creates a niche. So there's a lack of community support for them. In general, you don't find a lot of good resources around it because someone has not built a YouTube tutorial trying to talk about it. And in general, they just get disconnected. So one app-specific system can't really talk to another app-specific system, either because they are like two distinct systems, or they just don't have like the right set of APIs to communicate. So that creates like silos. So again, like coming to the issues, so they create silos and niches. So silos in the sense that these systems can't really talk to each other. Niches in the sense that there are a very limited set of people who know what to do. This is very resource intensive because you need to find the right set of people. You need to find the right set of infrastructure requirement to run these systems. And in general, like it becomes like eventually hard to do that. And it is very easy to get into the analysis paralysis scenario, wherein you can keep on customizing this over and over and over again, and you just don't know when to stop. This is something which we have been facing recently as well. So that's like a few issues with app specificity as well. So now, just to complete the code, so jack of all trades, master of none, and it goes like two oftentimes better than a master of one. And this is something which I feel that's going to be like that EVM sucks, but unfortunately it's not going anywhere because all the new chains that are launching are are choosing to go with EVM. So what's the solution? So is there something that exists, like which is picking the best from all the things, best of both worlds, like picking stuff from the application-specific side of things, picking stuff from the general-purpose side of things, and just combining them together? I would say no, but we can average them out together. So there are good parts of some certain systems, there are bad parts of some certain systems, but what we can actually do is just combine the minimal averages of them and get something which is good enough for most purposes. So that's something which I feel comes into the category of domain-specific chains. This is kind of like a new term. I haven't seen a lot of people using it, but this is something which I feel fits perfectly between a general-purpose system and an application-specific system, which is domain-specific chains, or like domain-specific systems, to be honest. So what is it all about? So what's the definition? So if we go about defining domain specificity, it's like basically taking a general purpose system and restricting it to a certain use cases. So it's not that you strip away all the important bits from it, you just customize it completely, but just that, okay, there is a general purpose system, you modify some parts of it which are relevant to you, or something which can make things better, until you get to like a good enough system. So the benefits of it is that it creates a low entry barrier because you already are familiar with the toolings available for it. There is good community support, and there are a lot of people working on those systems. But at the same time, you can customize it to like a really good extent because you know the system, there is tooling, you have worked on it, and it does not feel disconnected. Because if you have like a minimal set of requirements, you can have other applications that can communicate with each other on that particular general domain-specific system. So what are the examples? So most of the EVM-based custom L2s fall into this category. So recently we have Unichain, Sonium launched, Kinto, which is like a EVM-based system, but with KYC enabled. So all of these are like domain-specific chains, and most of the chains that are built using OP Stack fall into this category, that they give you an EVM-based system that you are familiar with. You can deploy contracts on top of it, which you have already written, and then you can have more customization on top of it by changing the block time, by changing the block parameters, and all of those kind of things. So what's the end game? Is there an end game? So I would say that the end game is nothing but app specificity with good tooling and user experience. So you can get to a point wherein the app-specific things don't feel very disconnected. You create a good ecosystem around it, and then you create a good set of tooling around it, and the community just comes together and builds something good. So this way, the apps don't feel disconnected. You still have like good amount of things going on. It's efficient, it's customizable, and you can do whatever you want with it. And the good news is that app-specific or like domain-specific chains are on the rise. So if you go onto like the Selenium Explorer, you find that they list down like the most active chains on their ecosystem. And out of the 20, there are just 2 of them which are like general purpose, but most of them are dedicated to a particular use case. So it could be either trading, it could be either KYC verification, verified transaction, and all of those kind of things. But yeah, that's like something which is happening these days. So coming on to the major part, like how to decide what's the best for you. And to get there, you need to answer, or like you need to ask yourself these 3 questions. What tech features would limit your application? Like, is there something which you need to care about, which the current like chain does not provide you, or you need to maybe customize the VM a lot so that you are able to do these kind of things? So for example, it could be like the block times. Like you're not happy with 12-second block time, you need much faster blocks. So that is like a limiting feature. So you need to be more bespoke for that. How much resource you want to spend on it? So that includes not just the resource you spend to build that system, but also to run that system. So in case you are spending some time or like money to get some developers to build on that particular tech feature, then you need to count for that. And then also, it's not cheap to run an app-specific system. You need to think about the infrastructure cost. You need to think about all the other things that goes around it. So I think Hilbert from like one of the previous talks mentioned how cheap it's gonna get, but that's something that you need to consider. And I think the one final thing is that how do you want to capture value? So the capture value mechanism is like, is that something that is enshrined in your protocol? You take fees, or is that sequencer revenue that you are after, and all those kind of things. So yeah, this is one of the things that I've found on Twitter. So it has like a really good mind map on how to think about launching an application. So let's say you have a dApp in mind, and you don't know what you're doing. It's something that you really want to experiment with. So you just build it on a shared chain, see how the community receives it, and then once that is getting a good product market fit, think about launching it to multiple chains. So once you do that, or you maybe you're just taking a proven use case and you want to do that, so just build across multiple chains, make it a multi-chain application. But at the same time, you hit the limits that, okay, your application is so popular that it cannot keep up with the demands of the system. Then you go something more bespoke, and then you build an app chain that can connect with all the other chains. So connecting is important, so it doesn't need to be in a silo. And to build an app chain, then again, you go back to the requirements on what kind of tech features do you want, what kind of customizations do you want. There is one more chart that I found, which was by John Sharp. So it's basically the app versus app chain cycle. And this is something which is really true and has been happening in the space. So starting from like the yellow box, apps on general purpose chain wants more customizability, sovereignty, and value capture. So they end up launching their own app chain. And then the app chain gets a lot of user, a lot of activity, and wants more value capture. So they go about having more players in the ecosystem to build across them, and then the app chain becomes a general purpose chain. And then the cycle repeats. One of the application on that particular general purpose chain gets big, and it keeps going and going and going. So that's something which you need to be aware of as well. And this is something which I think recently is happening with AO. So AO, which is like a app-specific chain, is thinking about opening its chain to have more applications built on top of it. So yeah. And this is where Stackr comes in as well. So Stackr SDK lets you build your own app-specific L2s. It helps you decide the 3 questions that you ask, that I talked about initially, and then you can have it your way. So Stackr is nothing but like a minimal roll-up framework. It gives you tooling to launch your own L2s. You can customize the state structure, you can customize the VM structure. It's not like, it doesn't bound you to anything like that. But yeah, keep in mind like the kind of design decisions that you make. It's very customizable, but it's really easy to get into like the analysis paralysis. So however, oftentimes the reason of launching L2 is wildly different. So it kind of sometimes goes beyond the 3 questions initially, and something which I asked on a Telegram chat, and the answer was this. So you just need to capture money. And how you do that? There are like 3 ways to go about it. 2 ways to go about it. And it's actually true because let's be honest, most of the chains that are launching as separate L2s want to capture the L2, want to capture the sequencer fees. And this is just the data from past year from Dune. And you would see that most of the revenue is upwards of $10 million. And it was like a crazy spike back in March. And then it has been like sustaining all of the, across the different months. So yeah, so fee capture is another thing that you can think about. So one of the ways of doing it is running your own sequencer. But with running your own sequencer comes in the issue of decentralization. So the applications are just stuck with that. It's an overhead because, again, you need to pay more to run the sequencer and all of those kind of things. And then L2-bit won't like you because then it comes into a different category of stage 0, stage 1, and stage 2 rollups. And there is something new which is coming up recently. It's like a very weird name. I don't like to use it, but it's called application control sequencing. So up until now, the web has been a structure wherein the protocol layer has very less value capture and the application layer has like the most value capture. This has been like a lot different in the blockchain scenario wherein the protocol layer itself has like the maximum value capture and the applications deploying on top of it is not like capturing a lot of value. And this has been like the the biggest reason of discomfort with the application. And then they go about launching their own protocol because the protocol capture values and then the application would eventually get value from that kind of thing. And this is something called as a fat app thesis wherein you get like the application layer itself to be fatter than the protocol, so that's where the value capture happens. And this is another thing wherein you don't force an app chain. The app chain should come naturally, and app chains are definitely not the end game, but you can think about like the different trade-offs. So launching an app chain, it has a very high cost, but you also capture high value, and that's some decisions that links back to the 3 questions. And then chains that share value, they are definitely like lower cost, but they are mid-value as well, because you can have domain-specific chains wherein, let's say there is a chain with most of the DeFi activity happening, you launch your application, but then the other applications on that chain would probably share value and those kind of things. So this is, an example of that could be Blast, like wherein like the sequencers commit to an application, but then again, you don't capture the 100% value out of it. And then there is app-specific sequencing, which is like the new thing coming up. It is mid-cost, but the value capture is something which is yet to see. We'll be seeing that in the coming days. But yeah, this sounds like a promising thing that's coming up. But yeah. So as an advice as an infra developer is that you don't need to build more infra. What you need to be focusing on is doing more of the app building and let us take care of you. And yeah, that's about it. Thank you.